Hi everyone, this is Rajeshwari. Today we'll be discussing on DBSCAN algorithm, which is a type of clustering algorithm. DBSCAN, that is density-based spatial clustering of application with noise algorithm. This algorithm groups data points which are closely packed together, and the data points which are away from the high density region will be marked as outliers or noise. So the key parameters in DBSCAN are F's and mean points. F's is nothing but radius of the neighborhood around the data point. If the distance between 2 points are less than or equal to F's, then they are considered as neighbors. For example, if we have 2 points A and B, if the distance between A and B is less than or equal to the specified X. For example, the X was specified as 4. The distance between A and B is less than or equal to X. Like it is 3, then they are considered as neighbors. Minimum points. The minimum number of points required within the X radius to form a dense region. So here we are specifying this number of points should be available in the X radius to form a dense region. That points are nothing but minimum number of points. So if we specify minimum number of points as 6, then there should be 6 points or greater than 6 points within the X radius to form a dense region. The minimum number of points should be greater than or equal to D plus 1. D is the number of dimension in the data set. So this is the detailed representation of DBSCAN algorithm. Here we are clearly mentioning the outliers in black in color. They are not included in any of the cluster. How the algorithm works. So here we have specified the mean points as 4 and X as 1 unit. So this X 1 unit, we should at least have 4 minimum points to have a dense region, to consider them as a dense region. So here in this X1 unit, we have more than 4 points. So this is considered as a dense region. And this region, we will see each data points to identify the code points. Here, this is the code point. This is identified as the code point because it has neighbors greater than or equal to minimum number of points. It has neighbors greater than 4. So this is considered as code. The other point which we identify here, it is the border point. This is available in the X region, the neighbor of the code point, but it is not the code point because it doesn't have minimum number of points as their neighbors. Noise. This point is away from the items. It is not part of any of the cluster. So this point is identified as noise and outliers. Steps for the algorithm. Initially, first we will be identifying code points. If the count meets or exceeds minimum number of points, if the neighbors count meets or exceeds the minimum points, then that point should be marked as a code point. Then we will be forming the cluster. Code point whichever identified, for that a cluster will be created. Once the cluster is created, the neighboring points of the code point will be added to the cluster. The density of connectivity. If we need to identify 2 points or density connectivity, we need to check the intermediate points, whether one of the point is chain, one of the point in the chain is a code point. So then we will be saying that those points are density connected. Then, if after processing all the points, any point that does not belong to any of the cluster, those points are labeled as noise or outlier. Pros and cons. So the advantages of this algorithm, it is robust to noise. We are already seeing it, how it marks the noise or outlier explicitly. So it is robust to noise, and we don't need to specify the number of cluster in starting with the algorithm. So it is an advantage. Limitation is sensitive to parameters. Here we have 2 parameters, X and minimum points. We need to be very careful by choosing X. If we choose a smaller X, then we might identify more points as outlier or noise. If we choose a higher value of f's, then the clusters might combine. Two clusters may combine to one cluster, so we will not be able to differentiate the behavior of the cases. Computational loss is higher, so this is the limitation of the algorithm. Thank you.